All right, I'm going to make some videos of the derivatives review. All right, so let's look at question number 1. All right, on this question, they want you to graph the derivative of f. So what you've got here is the graph of f, and your job is to get the graph of f prime. So you got to be thinking about how f prime is really a derivative, which is really slope. And so you really need the slope of all these different line segments. So as you look from left to right, if it's rising, you know it's positive. And then even though they give you the values of the coordinates, you really should just count. So this one right here really goes up 2 over 2. I'm not even going to draw that. So it's up 2 over 2. So that would give you rise over run of positive 1. Okay, this one here is down 3 to the right 3. So that's a slope of negative 1. Okay, this one from here to here, that's going to be a slope of 1, 2, 3, 4, 5, 6 going up, and 1, 2, 3 really over. So up 6 to the right 3, that would be a positive 2. And then this is horizontal, so that would have a slope of 0. And then your graph for f prime should be those slopes. It's really the graph of the slope function. So from this point to this point, you're going to graph 1. I'm going to graph it in red on the same coordinate plane rather than drawing another coordinate plane. So it's going to go up at positive 1, open end points on those because it's not differentiable at that sharp point there. Sorry, I have the hiccups. All right, and then from here to here, the slope is negative 1. So from there, open circle, to there, open circle, you should be down at negative 1. Then for this stretch that goes from 1 to 3, you should be up at 2, open circle, to 2 on the other end, open circle. And then here we are from 3 to 6, right there at 0, open circle at 0. So what you see in red, those horizontal line segments, that would be the graph of the slope function. So what you see in red is, well, this isn't supposed to be up here in red. So that was the blue function itself. Okay. And the slope of that was 0. And so the red that you see down here is that segment. So all those little segments, that's what you see in red is the graph of f prime. All right, now let's go ahead and move on to question number 2. So on question number 2, we're being asked to get the formula for the derivative, then evaluate that at negative 1 and evaluate that at 3/2. Excuse me. And that's it. We're not going on and doing a tangent line or anything. Okay, and it said to use limits. So that's going to be important. So what I'm going to do is I'm going to look at the limit as h approaches 0 of this, the difference quotient, f of s plus h minus f of s all over h, okay? All right, and that's going to be equal to f prime of s. So big part of this is going to be simplifying this part right here, which is the difference quotient. So the first thing you're going to do is you're going to plug in the s plus h goes in place of the input in the rule. So you're going to have we're going to go ahead and plug it in. We're going to have the square root of 6 times s plus h plus 7. That's the f of s plus h. Then we have to subtract f of s, which is square root of 6s plus 7. And then all of that's divided by h. And so we can't just put 0 in right now to evaluate this because the denominator would be 0. And then if we put a 0 in for the h in the numerator, we'd have 0 up there as well. So you have to remember the algebraic way you take care of that. You rationalize the numerator. You multiply the top part by I'm going to go ahead and distribute 6s plus 6h plus 7 plus the square root of 6s plus 7. So let me say that again. I'm doing the conjugate, and I went ahead and distributed the 6. Okay. And if I multiply the top by the conjugate, I have to multiply the denominator as well. Okay. All right. So now what's going to happen? Let me see if I can get that to page down a little bit. Nope. Okay. Get in here again. Back up to where I was. Okay. All right. A little more space there. Oh, well, let me see if I can just squeeze it in. Okay, so what's going to wind up happening as we take care of this, we haven't yet done the limit, so keep that on there, the limit as h goes to 0. But why you multiplied by the conjugate is this times this is just going to be 6s plus 6h plus 7 with no radical, because you're doing a square root of that times a square root of that. Then the inside 2 and the outside 2 are opposite, so they cancel out. Then the minus times the plus is minus, and then the square root of 6s plus 7 times itself would just be 6s plus 7, but be careful because you're subtracting all of that. And you still have the h together with the 6s plus 6h plus 7, then plus square root of 6s plus 7 down here. Okay. All right. So I'm going to move to the right on this one. Okay. So the 6s, I still have the limit. I'm not doing that yet. So that's 6s plus 6h plus 7 minus 6s minus 7. All of it divided by h times that long thing there. Okay. All right, so now we're going to be able to get rid of some things. So the 6s and the negative 6s would add to 0. So would 7 and negative 7. And then all I have on top is the 6h, so I know I can divide out that h. And so I wind up with the 6h on top. Let me keep the limit in there for just a moment longer. One more thing. So on top I have a 6, the h was canceled out. And then down here I have 6s plus 6h plus 7 plus square root of 6s plus 7. Okay. All right. And then at that point, you're ready to do the limit part. So you're trying to do the limit as h goes to 0. So when h goes to 0, this goes to 0. And so this now becomes, now we're evaluating it where we're thinking about the limit as h goes to 0. This would be 6 over 2 times the square root of 6s plus 7, because you're just adding. Okay, and you got the same thing. So it's 2 of those, and then 2 goes into 6 3 times. So that's going to be your final answer, 3 over 6s plus 7. Now what you just found right there, that right there is f prime of s, a formula that would tell you the slope of the tangent line wherever they want it. Okay, now they say, they don't talk tangent line, they just say find f prime of a. So we know f prime of s equals this. We're supposed to find first f prime of negative 1, so we plug that in, which is 3 over the square root of 1, which is 3 over 1, and that would be 3. And then after we finish that, we're supposed to do f prime of 3 halves. Okay, that would be, was it positive 3 halves? Yeah, positive 3 halves. So that would be 9 plus 7, that would be square root of 16 down there, which would be 4 really, and that would be then a positive 3/4. Okay, so on that one, they wanted you to find f prime, so that's this. Then they wanted you to find f prime of -1, and then find f prime of 3/2. Okay. All right. All right, let's look at number 2. Actually, this is number 3. On number 3, similar question, slightly more. It says find the derivative. So you're finding a rule for that. You're finding f prime of x. Then you're going to find the equation of the line tangent to the graph, okay, at a equals -1. Okay. So your plan should be to start by getting the formula for the derivative. And this one was also a use limits one. Okay. So you're going to get it all set up. So f prime of x would equal the limit as h goes to 0 of the 1 over x plus h plus 3 minus 1 over x plus 3. So that's the f of x plus h minus the f of x all over h. So that's what you're trying to do the limit of. You can't think of h approaching 0 right at the start, or you'd have 0 over 0. So what we're going to do, we're going to simplify the expression, the difference quotient, for a minute. So keep the limit in there and work on this part. So here's where you would multiply the top and the bottom here by x minus 3. And then on this one, the top and bottom needs to get multiplied by x, not minus 3, it's plus 3. It's the same as what you see there. And then on this side, I'm missing the x plus h plus 3 factor. So I'm going to multiply top and bottom by x plus h plus 3. Okay. All right, so we're doing that to get this together to have just a single term on top. So we're going to have x plus 3, but then minus x plus h plus 3 over that denominator, x plus h plus 3 times x plus 3. And then we've got all of that divided by h. And so if all of this is divided by h, okay, that's the same as 1 over h. Okay. So that divided by h is the same as times 1 over h. So you really have x plus 3 minus x minus h minus 3 all over that denominator. But then you also are times 1 over h, and times 1 over h means you have an h down here. Okay. And you can skip that when you get used to seeing it a lot and go right from there to there. All right, now I'm going to do a little simplifying before we consider the limit as h goes to 0. So x minus x would cancel out. 3 minus 3 would cancel out. And h is now a factor of the numerator, so I can knock the h out so that on top I have -1 over the x plus h plus 3 times the x plus 3. Haven't done the limit yet, so let me keep that in there. And then what we'll do at this point is get the derivative part. As h goes to 0, this would go to 0, and we'd wind up then with -1 on top, and then the x plus 3 squared. So we would get that if we did the low d high minus high d low over the low squared. We would also get that. Okay, so that's the formula for f prime of x. Okay. All right, so now if we know f prime of x equals -1 over the x plus 3 squared, then we can find f prime of -1 by just plugging in a -1 for the x. So that's going to wind up being -1 over 4. And that's the slope of the tangent line at -1. So that right there is m at the spot we're interested in. So we're going to get ready to do this equation, right? We're going to do the y minus y1 equation. And we'll put in our slope, but then we've got to put in the point. And really all they gave me was that a was -1. So you need to find out what is f of -1. What is the y coordinate associated with that? And that would be 1/2. So then you're going to come back now. So now you have the point that you're dealing with is the point -1, 1/2. And this right here is the slope. So you're going to have y minus 1/2 equals a -1/4, x minus a -1. So that's x plus 1. You'll distribute. Okay. And then add the 1/2 to both sides. And when you add the 1/2 to a -1/4, you get a positive 1/4. Okay, so on that one, you were supposed to do, the answers were this, right? Getting the f prime of x and then getting the equation of the tangent line was part B, and that would actually be all the way down here. Okay. All right, so let's move on to number 4. That one, we're being given a formula that represents a projectile, the height of a projectile over time. And so you don't need to graph it or anything, but what's going on is it's being fired straight up like this. And then of course it's going to come down, right? And if there's no wind or anything, it'll be straight up and straight down. Okay, so when we think about the sketch of the graph of that, it's going to do this. The height is going to increase. It's going to then reach its maximum height, and then it's going to come back down and hit the ground. It's not going to go below the ground. It's going to just hit the ground, go boom. Okay, so that's kind of the picture. And this right here would be the position, which is basically the height of that projectile in meters above the ground. And this is really the time. That's the t. Okay, this is the height. All right, you didn't need to know all of that, but it might help you to interpret the answer that you get. So part A said, find the formula for the instantaneous velocity function. So instantaneous velocity is really s prime of t. So v of t is really s prime of t. So we're not going to use limits. We're just going to use our little shortcut rules. That would be -9.8 t plus 30. So at t equals 1, the instantaneous velocity can be found by just plugging a 1 into that. 9.8 times 1 plus 30. And that would wind up being 30 minus 9.8. So that would be 20.2. Okay. And the units on that, since this was meters here, and this was seconds here, then the slope would actually be meters per second, because it's the instantaneous velocity would be meters per second, because you're looking at the rate of change in meters over time. So this would be meters per second. Okay. All right. And then you do s prime of 2. And that one turns out to be 10.4 meters per second. And notice how it's positive? That's because the projectile is going up. And at that instant in time, it's got a speed of 20.2 meters per second. And then positive there as well. So it's going up also at 10.4 meters per second. And then when it reaches this, and that's like here. So it's here, and then it's starting to slow down a little bit. Then it finally is going to be horizontal, so it'll have a slope of 0, and then these are going to be negative, and it'll be getting more and more negative, okay, at that point. All right, so that's the video for questions 1 through 4. So I'm going to post that, and then I'll keep making little short videos to make it easier for you to open.